And so remember, the formula for the equation of a circle is x minus h squared plus y minus k squared equal r squared. That's your formula. And in order to use this equation, what must you know? You've got to know what? You say it again? You've got to know the center of the circle. What else must you know in order to use this formula? The radius. The length of the radius. All right. So if you look at the first one, that first problem here, the circle is drawn for you. And remember, every point on this circle is a solution. So the circle is drawn for you. You've got to come up with the equation. So what's the equation of that circle? That's what you got to come up with. So again, what you think must you know? The center. Do I know the center? In this particular case, do I know the center? Yeah, what are the coordinates of that center? Now, let me say this. One other thing. Assume that each tick mark represents one unit. That the numbers aren't there.
Okay, where's your origin then?
Well, the origin is where the x and y axis intersect.
Oh, okay.
Those darker vertical and horizontal lines. Say it again. What do you think this? -4, 1, 2, 3, 4, and then 3. Okay, so that's your center. Right. Now, this one's easy enough to determine the radius because of how it's situated. So when you drew your circles, you remember if the radius was 7, you went 7 up, 7 down, 7 right, 7 left. Okay? So when I go down, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, the radius is 5 units. You can tell that the radius is 5 units. So remember, the radius is the distance from the fixed point. Remember the definition of circle? The fixed point. What's the fixed point called in the definition of circle? What's that fixed point they were referring to? The center. The center to a point on the circle. So going from the center to a point of the circle, if I go straight down, that's 5 units. Go straight up, that's 5 units. Go to the right, that's 5 units, and so on. So every radius, and how many radii are there? An infinite number. So every radius has what length? 5 units. So the radius is 5 here. Okay, the radius is 5. Now, once you find that, then you can come up with the equation of a circle. In fact, you had to do this on that worksheet you were working on a while ago. The only difference is that on that worksheet, I gave you the center and the radius, and you just plugged it in. Here, you had to determine that from the graph. So what's going to be your answer? You're going to say x minus a what? -4. Now, you have to come back and fix this, but right now, you're going to say x minus a -4 what? Squared plus y minus 3. So remember, your center, your x coordinate is h, and your y coordinate is k. Squared equal the radius, and what's the radius?
5.
And what must I do to that? Squared. But that's not the answer you give me. The answer you give me is a better looking answer. X minus -4 is the same thing as x plus 4. That's how I want you to write this. Squared plus on the test or worksheet, whatever it may be, if you leave it x minus -4, you'll be very upset with me. And then y minus 3 squared equal, don't leave it as 5 squared. You can tell me what 5 squared is. 25. So that's the equation of the circle, this circle. Over here, what's your center?
1, -1.
Okay, 1, -1. What's the radius?
3.
Radius is 3. All right, so we're just going to plug it back into the formula. So remember, h here is 1, k is the y coordinate, so that is -1. So in your mind, you have x minus h. What's h? I got to square that binomial plus y minus a -1 squared equal 3 squared. So I get, in terms of the answer, I'm going to get x minus 1 squared plus y plus 1 squared equal, and then 3 times 3 is 9. Now, if that was the square root of 10, the square root of 10, the square root of 10 is just what? 10. The square root of 100, which is 10. That's what you would put. You would put 10 there. Okay, now, so we have this, right? Okay, now listen to this part. Suppose that all you're told is that the endpoints of the diameter, I'm making this up, so it was a good thing, but I'm making this up. The endpoints of the diameter of a circle are, let's say, -3, 2, and I got to make sure I choose nice numbers. Let's say -1, 7.
Wants to graph these.
No. No. All right. So the endpoints of the diameter of a circle are -3, 2, and -1, 7. Now, I wanted to do this before I went to this, and I apologize. I'm going to go back to this for a moment. Because some of you were messing up with the domain and range. If I asked you the domain of this circle here, remember the domain, you go from left to right. So every point on this graph is a solution. So when you do domain and range, you can use those brackets, because remember, brackets you use with if it's a solution. Parentheses if it's not a solution, but all these are solutions. That's what you graph. You're graphing solutions. But as you go from left to right, for the domain, what is this x value right here?
-9.
-9 all the way to what?
1.
1. So your domain would be bracket -9 comma all the way to 1, meaning that if you look at any point on this circle, my x coordinate of any of those points will lie between what two numbers? Will be between what two numbers? -9 and 1. It won't be any other value. The same thing for the range, the y values. So the y value, go from bottom up. What's that smallest y value? -2, comma all the way to, what's this, 8? All right, so that's the idea with domain and range. Okay? All right, now let's just go back to this one. Okay, so the endpoints of the diameter of a circle are these. And you want to find the equation of this circle. Write the equation of the circle. In standard form. Okay, write the equation of circle in standard form. Well, first of all, what's the formula for the equation of a circle in standard form? What does it look like?
X minus H.
Squared plus
Y
y minus k squared equal
R2.
r squared. Don't say r2, say r squared. And in order to use this, I've got to know what two things. The center, and well, yeah, h and k, which is the center. But what else do I need to know? The radius. All right. Nowhere in that first part does it say anything about what the radius is, nor does it say anything about what the center is. Okay? Now, I am going to kind of draw a rough graph of this, so it'll give you an idea of what you may need to do. All right, so let me go ahead and sketch this graph. So if I were to sketch this, you have -3, 2, which is here. So that's an endpoint of the diameter, right? And you have -1, 7, which is here. So this thing that I'm drawing right here is the diameter of this circle. Now, how many diameters are there for a circle? An infinite number. So I'm going to draw the circle. Now remember, well, okay, I'm going to go ahead and draw the circle, and then I'll discuss what I wanted to say. Now I'm not drawing this very well. It may not even be this small or this big, but that's the idea. The diameter of a circle always go through what part of a circle?
Center.
The center. The diameter of a circle, remember high school geometry, the diameter of a circle always goes through the center. So the center has to be somewhere around here, right? Now you're not going to guess as to what it is because it may not be on one of those little nice tick marks. But you have the idea that the diameter of a circle goes to the center. So I want you to think about this. In this particular case, how can I determine the center?
Midpoint.
The midpoint. Very good. That was one of the reasons why we talked about distance and midpoint. So the midpoint of this diameter is the what?
Center.
The center. So you see, having a visual cue of this kind of gives you an idea of how to approach this problem. So on your test, you're going to be given the endpoints of the diameter. So you got to remember, all right, I have this diameter, the center, it goes to the center. The center is in the middle of it, so think midpoint. All right, so we got to find the midpoints. So the midpoint's going to be the center is going to be the midpoint of this diameter. So that's going to be my center. All right, so remember, what's the formula for midpoint? So you add your x's together and then do what? Divide by 2. Add your y's together and divide by 2. Okay? All right. So I'm going to go ahead and write those points over right here. So this is -3, 2, and this is -1, 7. So it's a good idea to label your points. So let's call this x1, then this is going to be y1. This is x2, y2. All right, so the center is the midpoint of the diameter. All right, now, as you were working on those worksheets today, before class, some of you, when you wrote your center, you forgot to put it in parentheses. So don't just say 5, 2. You got to say parentheses 5, comma 2, because it's a point. Remember, you write a point with parentheses. All right, so let's go ahead and plug in. So you add your x's to tell me what to write. -3 plus -1 divided by 2, comma
2 plus 7.
2 plus 7 divided by 2. Okay. I wanted this to be nice numbered. So can you just quickly change the 7 to an 8? It's no big deal. You can do it. Quickly change the 7 to an 8. All right, because I didn't want any fractions. All right, just change the 7 to an 8. All right, now tell me what the midpoint is, what the center is.
-2, 5.
So -4 divided by 2 is -2, comma, and then 10 divided by 2 is 5. All right. Now, if I had, now remember I changed the one of the endpoints, but this kind of looks like it's at -2. If I had done the 8 right here, see it's close to -2.5, right? But I remember it's not at 8, it's at 7. But you see where it is? Okay. All right, so I found the center. So that's how you find the center. So the endpoints are given of a diameter. You just, to find the center of the circle, you find the midpoint of the diameter. All right, now, so I got the center. What else do I need to use this equation?
The radius.
The radius. Okay, so let's think about the radius. Look at your diameter. Remember, the radius is the distance from the center to a point on the circle, right? Okay? Or, if you know the length of the radius, if you know the length of the diameter, then the radius is what? Half of that. Okay? So there are two approaches you can take. Probably the best approach is to look at the diameter. All right, so tell me, how can I find the length of this diameter?
Distance formula.
The distance formula. We learned about the distance formula. That was one of those worksheets you had to work on today. Distance. So remember the radius is half the diameter. Remember that from a long time ago, high school, for some of us? All right, so if I can find the length of the diameter, then I take half of it. That's it. All right, so the D here stands for diameter. All right, so let's find the length of the diameter. So the distance formula is what? Square root of?
Square root of x squared minus x.
X sub 2 minus x sub 1 squared. So you subtract your x coordinates from each other, you square them, plus, and then you subtract your y coordinates from each other, and you square. So that's your distance formula. So all you do now is just plug in. So let's find the length of the diameter. So we're going to say the square root of, parentheses, what's x2? Negative 1. Subtract x1, negative 3. Whatever that is, I square it. Plus, parentheses, y2, what's y2? 8. Subtract y1, which is 2. Whatever that is, I'm going to square. So that's where I'm at. Okay, now let's look at that first parentheses. I have negative 1 subtract a negative 3. If you don't remember anything about signed numbers, then just use your calculator. But the idea is this. Remember, when you subtract, we always change it to what kind of problem? Addition. So you have to remember, add the opposite. So basically you said negative 1, change subtraction to addition, and you added the opposite of negative 3. What's the opposite of negative 3? Positive 3. So negative 1 subtract a negative 3 is the same thing as negative 1 plus 3. And what's negative 1 plus 3? 2. So this becomes the square root of 2 squared. What's 8 minus 2? So that's 6 squared. So I get the square root of 4 plus what? 36, which is the square root of 40. So that's where I'm at. So the distance of the diameter, or the length of the diameter, is the square root of 40. Now don't simplify the square root of 40, because here's why. Now it's different than what you did in that first worksheet. Because in the first worksheet, you were asked to simplify the radical, right? So if you had the square root of 40, you would have simplified it, correct? But don't do it here, because here's why. Watch what's going to happen. Okay. So it means that the radius, then, is the length of the diameter, which is what? What's the length of the diameter? Square root of 40 divided by what? 2. Now, don't make the mistake and say that's the square root of 20. Because that's not 40 divided by 2. That's what? Square root of 40. The square root of 40 is not 20. So don't do that. All right? And again, don't try and simplify the square root of 40, because in a little while you're going to see what's going to happen. All right, so here we go. So now I have the length. I have to have the length of the radius, right? And I have the center. So let's plug into the formula. So x minus h. What's h? What's h? Negative 2. Your center. This is hk. Negative 2 squared plus y minus what? 5 squared equals the radius. What's the radius? Square root of 40 divided by 2 squared, right? Okay. Is that how you want to write it? No. No. All right, so listen carefully. So you're going to say x subtract negative 2 is what? X plus 2 squared plus y minus 5 squared. All right, now let's look at this. The square root of 40 divided by 2 squared means this. The square root of 40 divided by 2 times itself, right? Oops, can't see it. Times itself, right? What's the square root of 40 of the square root of 40? 40. What's 2 times 2? 4, what's that? 10. So this is 10. So that's why I didn't want you to simplify this, because you'll be squaring that radical and the radical goes away. So this is the square root of 128. Leave it as the square root of 128, because when you square it, it's going to end up being what? 128. All right, you're done. Let's look at another one. Okay, so that was number 1. This was number 1. All right, let's go to number 2. All right, let's suppose this time the endpoints are these. So let's say it's -5, -2, and now these are the endpoints. Same directions. All right, same directions. So endpoints are these. I just got to make sure that my center are nice numbers. Let's say -3 and 0. Okay. All right. Now remember, those are our endpoints of the diameter, of one of the diameters. Now, how many diameters are there in a circle? There's an infinite number, but those are a pair of the endpoints. Okay. There's an infinite number of endpoints of a circle. That's just 2 of them. So if you think about it in your mind, okay, this is a diameter. I know the diameter goes through the what? The center, and the center is in the middle of the what? The circle, which is also the middle of the diameter, right? So when you think center, middle of the diameter, you think of what idea? Midpoint. Midpoint. So you use the midpoint. So I have to find the center. So the center is going to be the midpoint of this diameter. All right, and so basically, I'm going to label this x1, y1, x2, y2. So to find the midpoint, which is the center of the circle, you're going to add your x coordinates together. So I'm going to say -5 plus what?
-3.
Divided by 2, comma, -2, then you add your y's, -2 plus 0 divided by 2. So what's the center of the circle? -8 halves, which is -4, and then -1. So that's the center. In order to write the equation of a circle, what else must I know? The radius. Well, how can you find the radius given the endpoints of the diameter? Find the distance of the diameter and do what to it? Take half of it. All right. So remember, the radius is half of the diameter. So let's find the distance, the length of the diameter. So remember the distance formula. So you subtract your x coordinates. So -3 subtract what? Not -1, -5, right? Squared. Plus, then I subtract the y coordinates. 0 subtract what? -2 squared. All right, so that's where I'm at. Okay, square root of. What's -3 subtracting -5 the same as? -3 plus 5, which is 2, right? But what do I do to that 2? Square it. What's 0 subtract the -2? +2 squared. So I get the square root of 4 plus 4, which is the square root of what? 8. All right. Now don't simplify that, because you're going to plug that into your formula. The square is going to go away. Now be careful though. The length of the radius is not square root of 80. That's where some of you are going to mess up. You're going to plug this into the formula. That's not what you plug into the formula. What do you plug into the formula? Half of that. So you got to remind yourself, all right, I found the length of the diameter, so the radius then would be the square root of 8 divided by what? 2. And don't make the mistake and say that's the square root of 4. You can't reduce the 2 and the 8, because that's not really 8. That's the square root of 8. Square root of 8 is 2 point something. Okay? All right. So then we're going to plug that back into the formula. So I have the radius and then I have the center. So the center, remember, is HK. All right, so here we go. X subtract H. What's H? Negative 4 squared plus Y subtract K. What's K?
-1.
Negative 1 squared equal the radius. What's the radius? Square root of 8 divided by 2. What must I do to that number? Square it. Okay, don't leave it like that. I expect you to go further with it. So the answer is going to be, instead of saying x minus negative 4, you're going to say x plus 4 squared plus, and then what? Y plus 1 squared. All right, let's think about the square root of 8 halves. I'm squaring that. So that means the square root of 8 divided by 2 times itself. Right? What's the square root of 8 times the square root of 8? 8. What's 2 times 2?
4,
What's that?
2.
2. So that's your answer. Okay? All right, let's do one more with this, and then I'll give you your in-class worksheet. All right, number 3. Okay, so number 3. Let's suppose that my endpoints are, negative 9, 2, and 1, 6. Negative 9, 2, and 1, 6. All right, so if I'm going to write the equation of a circle in standard form, what 2 things must I know? The center of the circle, right? And the what? The radius. Okay? So I can find the center of the circle by finding the midpoint of the what? The diameter. Because the diameter goes to the center. So let's find the midpoint of this diameter. So let's call this x1, y1, and then x2, y2. So the midpoint, which is going to be the center here, is going to equal, all right, you add your x's together. So you're going to say negative 9 plus 1 divided by 2, comma, and now you add your y's. 2 plus 6 divided by 2. So what's going to be the x-coordinate of my center?
-4.
Negative 4. Negative 9 plus 1 is negative 8. Negative 8 divided by 2 is negative 4. What's going to be the y-coordinate of my center? 2 plus 6 is 8. 8 divided by 2 is 4. All right, so I found my center. So I found the center of the circle. What else do I need to know to use that equation? The radius. Right. It is easier to use the diameter and not the center and one of the endpoints. Just find the length of the diameter and do what to it? Divide by 2. That's the easiest way to do this. So the length of the diameter will be the square root of, and then remember you subtract your x-coordinates. So what's x2? 1. Subtract x1, which is negative 9. What do I do to that? Squared. Plus, now you subtract your y-coordinates. y2, which is 6. Subtract y1, which is 2. Whatever that is, I squared. All right, we're going to simplify this. 1 subtracting negative 9 is 10. I'm going to have to square that. 6 subtract 2 is 4. I have to square that. So I get 100 plus 16, which is the square root of 116. Okay? All right. All right, so then the radius would be the square root of 116 divided by what?
2.
2. So then I can plug into my formula. X minus h, what's h here? -4. So there's your h, there's your k. -4 squared plus y minus k. What's k? 4 squared equal the radius squared. What's the radius? Divided by 2. All right, so that's where I'm at. So now the answer, you're going to say x what? Plus 4 squared plus y minus 4 squared equal, and let's go off to the side and figure this out. So the square root of 116 divided by 2 times itself. Square root of 116, square root of 116 is just what?
116.
2 times 2 is 4. Okay. What is 116 divided by 4? Is that a whole number?
29.
Is it 29? If it ends up being a fraction, just leave it as a fraction. So 29. All right, so that's all you do. Okay, now, just out of curiosity, I'm going to ask you this. On the worksheet you had to work on today, this equation like this was given. And then one of the questions is, what's the center? So what's the center of this equation? -4, 4. Then you were asked, what's the length of the radius? You would say what? Given this, forget about everything else. What's the length of the radius? What's the length of the radius? No, you're forgetting. Remember, this is r squared, right? So you would say r squared equal 29, so r would be the square root of 29, correct? All right, so the radius would be the square root of 120, or square root of 29. But then you better start asking this. Well, I thought the length of the radius was this. Now you're saying the length of the radius is this, right? You do know that those are the same thing, right? Because what can you do to this? Reduce it. You can simplify this. What perfect square, I just want to show you, what perfect square goes into square root of 116?
4. I mean, no, 16.
16?
Or the
4, right?
4.
4. So that's square root of 4 times 29. There's a 29 right there. What's the square root of 4?
2.
Square root of 29. But remember, the radius up here, the radius is square root of 116, which is this, right? Divided by what? 2. And then the 2's divide out, you're left with what? Square root of 29. Okay? All right? Okay, so just wanted you to be aware that when this is given, you would take the square root of this. So remember, if this number right here was 100, you would say the radius is what? 10, square root. If this is a square root of 37, I'm sorry, if this is 37, you say the radius is what? Square root of 37. That's what we did. But then when we find the distance, remember I told you, I said, don't simplify this, right? Because you'll be squaring it and the square root goes away. But I just want you to be aware of the fact that when this is given, the radius will be just the square root of this, and I want you to also know that that is the same thing as this. Because when you simplify this, you get this. Okay? All right. Okay, so you have 3 problems that you can use on this in-class worksheet. You are going to have one problem in your test Wednesday where the diameter is given. The endpoint of the diameter is given. You have to find the equation of the circle. So that's a process you go through. Okay? All right. So let me go ahead and give you that part.